We are Team 5, also known as Quantum NDE, and welcome to our presentation. Corrosion under insulation causes wall thinning on pipes and vessels that are manufactured from steel. Wall thinning compromises the structural integrity of the pipe, posing a detrimental hazard to plant workers, particularly when the pipe is pressurized. Over 20% of major oil and gas incidents reported within the EU since 1984 were associated with corrosion under insulation. Alongside threatening health and safety, corrosion under insulation costs the global economy £4 trillion annually, with costs of £28 billion being in the UK alone. This corrosion is not visibly detectable without the removal of the surrounding cladding, which is a costly and time-consuming process. CUI mapping using non-destructive testing and evaluation methods is estimated to cost less than a fifth to perform when compared with destructive methods. Hence, the aim of the project was to create a system to detect and image corrosion under insulation without the removal of cladding by using pulse eddy current testing and quantum well Hall effect sensors. Pulsed eddy current testing involves the excitation of an illuminating coil with a pulse signal and the evaluation of the resulting magnetic fields, in this application by using a QWHE sensor. When wall thickness loss is present on the pipe, the formation of eddy currents on the pipe surface is influenced due to the change in magnetic permeability of the sample, allowing analysis of wall thinning. The QWHE sensor was developed at the University of Manchester 15 years ago. It offers a wide dynamic range. It is highly linear, sensitive to low frequencies, and has low power consumption. Overall, we determined it to be the best for this application. Our system was comprised of an external control to supply the components with power and signals, an optimized excitation coil to propagate the primary magnetic field through the pipe, a low noise detection circuit incorporating the QWHE sensor, and an absolute position encoder to allow for imaging capabilities. The data obtained from this scanner system would be sent to a computer for image reconstruction. A scan was simulated with the scanner placed in different positions above the floor. The data from this was used to digitally reconstruct an image of the floor. The image on screen was constructed by using carefully selected points from the simulations, which were extrapolated to the rest of the image. This would be our optimal image. However, limitations of the modelling software meant the images reconstructed using analytical readings were not as intuitive. Here we can see 10%, 20% and 30% wall thinning respectively. An image with no corrosion would be completely black. Our system can detect corrosion, but not faithfully reconstruct the surface of the pipe. This still provides value to the industry. Overall, the system was carefully designed and simulated in software. The main limiting factor of progress was the university shutdown, as it suspended all practical work. Therefore, physical implementation and testing of the system was not possible. Hence, when permitted, the system developed could be physically implemented and tested.